The reading packets?
They're on the way.
Oh.
Okay, children. Thank you for starting independently. A little update as you're starting your warm-ups. Don't forget to include yesterday's warm-up. If you were absent yesterday, the homework that I'll be stamping right now, you should be able to complete if you keep up to speed with our lecture today. And everybody else, your homework from last night is the foundation for today's notes, as is always the case with homework. Anybody have any questions for me? Are there any Unit 1 exam makeups? Does anybody need to take the Unit 1 exam still? Okay. So next week, it sounds so wrong, like I didn't talk so high school about that. I don't know, but it sounds so like murky. Uh-huh. Anybody else need their homework stamped? Heading issues?
I
I said assignment.
What you title on it is what goes right there. This is food what happens. Thank you.
This far away from the door on your side. Can I still get it if I get?
Yeah, you can like, you might have to climb over tools, you might get stabbed.
Okay.
You're good to deposit, here's all your mail and later.
I have to deposit? We go to people to pay my. You might come.
And you said students don't get mail next time.
Who said it?
Mrs. Olivia.
She was there.
Yeah.
Okay, great.
Wait, is she the kind of like this tall?
Yeah.
Yeah.
Yo, bro.
Should we get the you have homework from yesterday if we weren't?
Absolutely.
Alright.
All students must have an entry for all days. Who needed a Unit 2 reading packet? Feinberg, you also?
Yes.
Help in your class? I was actually on your beats.
She doesn't have a case of your son. She's going to the thing.
Okay. I think we're there now. There are no Unit 1 makeups. You've done warm-ups. We have stamped homeworks. Wednesday's movie. Only plays on Wednesday, not Thursday, because Thursday, as I believe you've heard, is back to school night. Everybody knows this? So this week there will not be a Thursday showing, just Wednesday. I'll try to put a trailer up on Bookface. The movie Wednesday night, I have kind of mixed feelings. So first, the good. It's interesting science. It includes the actual scientists discussing their research. So the guy says, first I saw this, which caused this, and it's like the PhD standing in the place where he studied the stuff. That article you read about, oh my god, cell phone? I got a glass in my eyes. The Wolf Effect, that article that you just read, the second one, Feinberg with cell phone.
This is relevant.
I know it isn't. What's it called? The Wolf Effect article. One of the key authors of the first fundamental paper on wolves in Yellowstone goes to Yellowstone and talks about the wolves in Yellowstone. And like seeing nerds talk about their science, I think, is sort of rad. It's the only movie, I think, where the primary researchers talk about their research. Second of all, the footage is kind of rad. A lot of it is like weird slow motion, like crappy, like not good footage. But there's a few little bits of like glamour shot wolves in the wild. Like really, if you have any appreciation for wild animals, there's like a few sequences that are like jaw-dropping. And stay to the end for the credits, where they show a pack of wolves circling a bison. Like, stellar wildlife footage. And it's short, so it's very easy to watch. The part I don't like is the movie has this strange, like, native fetish theme. Where there's like random like drums with a wind flute and like chanting. And I mean, for all I know, it's like some legitimate music, but to me, it just feels like retired ponytail, like Summerlin types, like in the studio, like, ooh yeah, that sounds really Indian. I don't know. We all appropriate culture. It's a very natural thing. We all like to do that. It's a human universal. But man, I'm super sensitive when people like start telling this like mythology of like all Native Americans being like naturalist spiritual shamans. Aside from the totally cheesy fetishizing of Native American themes, the rest of the film is pretty great. And it's short and it has neat footage. And it's like a really good explanation of the Wolf Effect stuff that you may have just read about. So it only plays Wednesday. I'll try to get the kids to put a trailer up on Bookface right now. Then Thursday is back to school night. Are there any questions about anything from yesterday or today or transitioning in units or having finished unit 1? Does anybody need me to answer questions before we get to the food web? Anything at all, because once I get going, I really want to stay on. Last call. Please bring up your food webs to me now.
just this, right?
The papers, the big food webs. Yeah, the big papers, right.
I don't think it has a lot of names on it. One of the names.
I don't need your names, I don't need your names.
And then
You're not gonna get credit for it, just bring me the papers.
knowledge. Go for it.
Next person, will you wind it up next to this one? Okay, we'll put the other end of Next person, will you wind it up to the right of this paper? I need a stable front plastic. Just hold that thought for a second. And open that drawer. The middle one? Yes, that one? Yes, two of them. Thank you, child. Right there. To the left corner. And then will you tag up the last one? Thank you. All right. Thank you for making these ridiculous food webs. I gotta warn you that the assignment that y'all did yesterday is pretty much 4th to 7th grade level. Steps 1 through 4, honestly, I stole that from an education program that works with youngsters. And I made questions 5 through 11 relatively easy so you don't have the homework done. But I do intend to get to some real actual nitty gritty today, and then a lot more of it tomorrow. As always, my intention is that you would have some basics on paper. And then I would add a couple of terms that might be new or a couple of concepts that might be new. For those of you who are absent, you can fill in 4 through 11 based on what happened in class today. Let's start with number 4. Could I please have a sample food chain? Anyone's fine, I don't care. Longer, we've got 5 or 6 species, maybe 7. Anybody have one with 7 species? Anybody have one with 6 species? Yeah, Amy.
Elderberry bush, mouse, California king snake, bobcat, coyote, mushroom.
Coyote what?
Mushroom, like a deep desert.
No, I'm gonna put that in. Okay. Anything that could eat the coyote though?
Blackbird.
Black bears don't hunt.
Good.
What?
Not mine.
Yeah, that'll work. And just to make sure that we're all on the same page, like, I'm gonna guess that for every one of you, this is insultingly obvious, but just to check, you all know that we call these producers because they use nutrients in their surroundings and energy from their environment to create macromolecules that are the building blocks of life, correct? Everybody understand that? Producers? If you don't know those words, the nutrients from the environment and energy from outside to make macronutrients, you've got it all out. Okay, and then this goes into a consumer, which goes into another consumer, which goes into another consumer, which goes into some other consumer, goes into some other consumer. Anybody know how we differentiate these consumers? Yeah?
primary consumer.
That's right, because it is the,
Or
anybody speak Spanish? What's primero?
first.
So it is the first consumer. Primary consumers are by definition herbivores, because they're eating some producer. Agreed? And then things which eat herbivores are called secondary, because they're the next in line. And then consumers who eat predatory consumers are tertiary. There are many tertiaries. How many of you were aware of this terminology from 7th grade or 9th grade or something? Okay. In this part, I'm just kind of checking my bases. Every unit of apes in the first day, I'll be like, do y'all remember the 3rd grade talking about the water cycle? Like, we kind of got to make sure we all have our basics, okay? There are other terms for the consumer at the top. What are those terms for the consumer at the top? If you wake up and answer the questions, it goes a lot faster. We get the interesting stuff. Come on. Apex predator is one word. What else? These are the top trophic levels. So we call them apex predators, or anybody know the other terms? Peak predator. We call them top predators. If you didn't know those terms, make sure you've written them down. They will become more common. And Ulysses, I don't know if you heard, but you're in the wrong seat. You move up one. I changed the seating chart yesterday. Apparently someone already told Serena. And who else did we have to tell today?
Was I supposed to move?
You're in the right spot now. All right. Anybody need any of those like very basic labels? Producer, primary, secondary, tertiary, top, apex, peak. Okay, just checking. A food web or a food chain shows which types of interactions between species. The flow of energy by means of doing what? Eating. This is predators and prey, food sources. This is a dietary set of connections. And does anybody know one very obvious reason why these papers are woefully inaccurate describing the ecosystem of the Sierra Nevada? Like, what is the most blatant thing that this does not cover about the real actual Sierra Nevada? Yes?
So like eating each other, like the competition between the animals?
Well, that's interesting. We'll come back to other relationships between species, but you're right. But what's like the most fundamental, like how many species were on your paper?
Not that
38?
There's way
There's a lot more. The Sierra Nevada has like, I think 450 or 520 native bird species and some unknown number of thousands of migratory species that live there at some time. Hundreds of mammals, a few dozen reptiles and amphibians. If I have no idea how many insects. I mean, insect diversity in the Sierra Nevada and flower diversity in the Sierra Nevada. California has the most diverse population of plants per mile as a statewide average of any place on earth except Indonesia. So who knows how many thousands of plants. So you all realize that this is like grossly overly simplified, right? The real food web, if it included all the species, would have a lot of arrows. But then something else comes up. A food web maps dietary relationships. Which relationships are not captured here? Decomposition, that's an important one. And remember, I told you on purpose not to include it, but decomposers do this. They downcycle macronutrients back into basic nutrients. They disassemble the castle of Legos, so you have all the little pieces to build another castle of Legos. You ever understand this? Super basic, I hope, decomposers. Still just doing the really bare bones fundamentals. I swear we'll get to nitty gritty, but we want to make sure that we've covered all the bases. A term you have to know, which we will use in this class, is the distinction between macromolecules or macronutrients, which are like big compounds built out of a lot of little pieces, like DNA is a macronutrient or macromolecule. You could not get to the hose escape? You did, stellar. Will you please throw that in the back of my truck? Are those all black?
Yeah.
I want it not black. Send him in, send him in. He's got nothing going on. I mean, that's anyway.
Oh.
You're the worst person ever.
I really pulled my whatever.
I want to hear about that.
You broke your fish tank.
Really?
You know
The
what
crack?
you did?
Oh, if I did.
I would have been so happy.
Yeah. I had some super petite student many years ago.
Yeah.
She was like 90 pounds, like shoulders, and like she was like one of the smallest people your age that I have ever seen. And one of my TAs was like, "Hey, throw me the keys." And I threw the keys, and right when I did that, that girl like stood up and turned around and was going to the bathroom or something, and she just hadn't been paying attention. Literally like walked temple to my whole entire keychain, which at that time had a heavier carabiner on it. And she took it to the dome and went straight to the deck and got up like totally didn't know what was going on. It was amazing. It was one of the most classic moments in my career. Yeah. Yeah, I don't care. Can you imagine, like, why do we have to talk about this? What if I said no? You go anyway. I wouldn't make you like pee in your water bottle. Now we're all thinking about what he's doing in the bathroom. I hate that. When you come back, you see if he washed his hands, you know, like everybody just wonders. He's home for a long time, he's doing number 2. Alright. This is missing decomposition. And that would be another set of arrows because essentially every species here depends on the flow of nutrients. But most of us can only take them in macro form and just modify them a little bit, break them up a little bit to make the other stuff. Everybody understand that? Are we all clear with this concept? Do you know that you're made almost entirely out of like 6 elements? More than half of your body is just 6 elements. And the other half is mostly another 4 or 5, I think. About 98% of your body is just about 10 or 11 of those. And then there's like some piddling percentage, which is a blend of all the other crap up here. You've got a little of everything. And decomposers break that down into basic pieces so you can build the bottom of the food web. Okay? What else is missing? Well, what other types of relationships did we not map? Yes? I guess so. Well, let's ignore the humans for now. Humans are going to come mess around with this thing, but we could see our impact on a lot of relationships that aren't just food. What else? Like if you get rid of oak trees, things that eat the oak trees are bummed, but who else? Yeah.
Oh, I was just gonna say like sunlight to plants.
Yeah, but those are not relationships between species. Like if you get rid of the oak trees, the acorn woodpecker and the oak moth larva don't have the food, right? But are any other species impacted? How?
The species that eat the species that eat them.
Okay, so there's like the ripple effect in the food web, but there's also the habitat issues. Think of how many species, either by accident or passively, provide homes for others. And then, here's something else. Trees build an environment. Trees change the humidity of the soil. They change the temperature of the land. Are you all aware of that? That like an oak tree drops leaves, which prevent evaporation so the soil holds more moisture? Do you know that? So there's plants that grow underneath a tree that aren't living in the tree. It's not habitat. But the tree engineers the conditions for those plants in the understory. Anybody know what we call those species that change the environment? Yeah?
Is it keystones?
Nope. But it's a type of keystone. I mean, what about the beavers? What do they do?
Like-
It was in your article. That's right. What would you call the job of making dams? Like if you were like a person doing the job. What if you were the one designing the dam?
Architect.
Engineer. So check this out. These don't capture all possible relationships. Your food webs are a grossly simplified map of the dietary options. But, must know this, we're going to spend a whole day on block day discussing them. There are community level interactions. Like decomposition, which cycles nutrients. Like symbioses, anybody know what a symbiosis is? Yeah?
Like mutualism,
Those are examples of symbiosis. What does that mean?
like when another animal benefits or like has something that benefits another species.
Yeah, it's like even if it's not a benefit, it could be a constant relationship,
Yeah.
a long-term ongoing relationship. So do you all realize that you can't digest milk or meat unless you have bacteria in your stomach? And those bacteria in your stomach suck at making a living, so they can only survive inside your stomach. You give them protection from the bully bacteria, and they give you a food stream that is more diversified. Symbioses, are you aware of these? Remember, we don't have symbioses on this map. If we added the symbioses, it might just make these random two-way arrows. Things that benefit each other, right? Then we have the engineer species. The way that crocodiles make wetlands, or that beavers make wetlands. Oak trees providing moisture to the soil. A good definition, and I see very few of you taking notes, it's your funeral, I don't care. A very good definition of engineering is species who change physical characteristics of their environment. And I'm sorry about this confusion, but there's a lot of terms for engineer species. People call them physical engineers, ecological engineers, environmental engineers, or engineer species. That all means the same thing.
This is the only other one.
Now we have to follow.
Yeah, there was another one.
Checking files, leave it in the greenhouse, use the green key to unlock the greenhouse, but don't have the attention to it.
This baby has it.
Inside the greenhouse, along the right, there should be like 3 or 4 roses stacked. I want something that has a bit of
regulation.
Engineer species change the physical characteristics of their environment, like making it hotter or colder or wetter or drier, deeper or shallower, flatter or steeper. They change their environment. And you should know there's many different types. People call them physical engineers, environmental engineers, ecological engineers, and it's all the same concept, it just has a bunch of different terms. A lot of ways to say it. Then there are the habitat relationships. Remember how we said that acorn woodpecker is bummed, but so is the hummingbird? Hummingbirds don't eat oak trees, but they do make their nest in oak trees. Does that make sense to everybody? Habitat relationships, yeah.
Symbiosis with habitat.
I guess so, yeah. I wonder if habitat relationships are considered symbioses. Well, that may not be a two-way street. So I think that's called, anybody know what it's called when one species benefits and the other doesn't have an interest? Commensalism?
Yeah.
Yeah, that might be a commensalism. Yeah. What? That's right, if one is hurt and one benefits, it's parasitism. If they both benefit, it's mutualism. Yeah, and one last thing. How many of you have heard that like killing off all the sharks is not a good idea? Getting rid of all the wolves in Yellowstone was not a good idea. Why? Yeah. Speed.
Oh, because they like kind of maintain the populations of other organisms, so they don't overpopulate. Kind of keep everything. in check.
What would you call that to control things? Regulation, yeah, that's right. There are some species here which regulate the conditions for the others. Like you saw with the wolves in Yellowstone, and tomorrow in the in the slideshow, I'll show you a bunch of other examples of regulation species. All right. Maybe we are moving on. Your food webs help us make food chains, but they're missing critical relationships that are called, vocab term, sorry that I didn't underline it already, community level interactions. And you might imagine, if you could visualize this, imagine I had a clear sheet. Have you ever seen those construction plans where you put like a clear sheet on top that shows where the plumbing goes and another clear sheet on top that shows where the wires go? Y'all seen that?
Yeah.
Imagine I had a clear sheet on top with a few separate arrows that connect the decomposer. Then another sheet that just shows symbioses like the bacteria in your gut sort of stuff. And then another layer that shows the ones that provide habitat for the others. And then another layer where species depend on the engineering effect of others. That would get pretty complicated, right? Tomorrow, we're going to talk about all of those types of connections. But today, we're going to keep it simple and just focus on the food web. It's a good thing you had it on your laptop. Jose Caballero last. I dropped my cell phone, so I'm sure that some of you might chuckle if I break mine. But if you break your phone, I will laugh at you. Safest place for your phone is in your car, home, maybe your backpack. I could find you a really safe place for that. All right. Which organisms are at the top of everybody's food chain? There's like 4 or 5. What are they?
Black bear, red-tailed hawk, mountain lion.
Black bear, red-tailed hawk, mountain lion. Anything else on the top of someone's? Great horned owl. Yeah. Debatably coyote, debatably bobcat. But I don't know. Yeah.
I also said the California bat. Is that accurate? Because it said like, no.
I don't think so.
Oh, because it's a small.
What do you call those animals at the very top? Apex predator, top predator, peak predator, yep.
How do you spell that word? Apex?
Apex. You ever heard of the band Aphex Twin? Apex is A-P-E-X. It's Aphex without the H. What do those animals have in common? How do you describe them? How do you know that you're looking at an apex predator? There's one really simple definition that we use in ecology for those. Yeah.
For carnivores?
No, there's a lot of carnivores. A mouse is a carnivore.
Nobody eats them.
Nobody eats them when?
No.
When they're healthy adults.
Cookies.
Yeah! You don't need a lot of back, but I appreciate the effort.
Okay.
A peak predator is one who is not eaten as an adult. Great white shark, once you're a grown up, nothing kills you, or nothing eats you. Technically, there's an interesting thing about great white sharks. Interesting thing about great whites. You all realize that they do get killed by killer whales sometimes? But killer whales don't target great whites as a food source, they just kill in defense. And sometimes they'll eat them, sometimes they won't. You aware of that fact? Well, what's another species globally peak predator, apex predator?
Brown bear?
Yeah, maybe. What else? Nothing eats a milk, brown bear. What else? What?
A whale.
Which whales? That's an interesting fact. Do you guys realize that a blue whale is a primary consumer? Maybe secondary? But they're still the peak, because nothing eats them as an adult. You understand that weird exception? Yeah?
Would we count?
Would we count? Great question. I don't know, it kind of depends. Because I can kill a great white, right? And I can kill a lion. In bare naked hand-to-hand combat, we are not peak predators. Y'all agree, right?
Yeah.
I mean, I'm pretty sure that, like, a determined bobcat could take down a feeble adult. We are, however, the planet's apex predator because of one thing that we share. It's not just our brain, it's our culture, which gives us technology. So I'm a gun nut. I have like tons of guns, I hunt, I make my own ammo. And with my guns, I could go kill, what was the name of that poor lion that got shot by some jackass dentist? Cecil. I could go kill Cecil the lion if somebody hadn't already killed him. Right? But of course, in hand-to-hand combat, pretty sure Cecil would win. I don't know how to build a gun on my own. I have intelligence, but not enough. I could probably, if I had the right tools and a bunch of time to figure it out, read some diagrams about how to build a gun. I know people who build guns. And I have some metalworking skills, so maybe. But you know what I could never do? I could never mix gunpowder. I don't know how to find those ingredients. For modern gunpowders, I don't know how to do that. I don't know how to make the cartridges for the ammo. I can play with lead. I can mold the projectiles. But you understand that my intelligence is not enough. I am not on my own an apex predator. I need to rely on my culture, which is the currency, the economy, the inventiveness and resourcefulness of others, manufacturing and trade. Okay. By the way, fun fact. Anybody know how you define a predator? Like a blue whale, they eat krill. Are they predators? No, they're not.
Is it like active hunting of animals?
How would you define active hunting? That might be what you mean. Yes?
Maybe like stalking.
Sort of. Yeah.
Extending calories to drink calories.
What's the difference between a blue whale stalking whatever a bunch of krill versus a lion chasing down an impala?
using a lot more energy.
No, it's not an energy measurement. Predators target an individual prey organism. Anybody know the largest predator to ever live on the earth? What type of animal was it? Yeah,
Alligator.
no. What? It was not a reptile. Hint, it wasn't a dinosaur. Hint, it's still alive on the planet today. If I could be one animal, I would be this animal. I'm obsessed with this animal. I've touched one.
Fish.
Not exactly.
Oh, no, that one.
Which fish do you think is the biggest predator? Great whites are pretty big.
Whale
What?
shark.
Whale sharks do not target individual prey. They're filter feeders. What?
It's a giant squid.
What eats giant squid?
Sperm whale.
The largest predator to ever live on the earth.
Sperm whale?
The sperm whale. It is the largest animal that has ever lived and still targeted individual prey items. Coincidentally, it may be one of the only directional trends in evolution. It's one of the only directional trends in evolution that predators keep. Like the largest predator has always grown in the history of life on Earth. But anyway, that's just a fun little fact, and that's a little bit of conjecture. That's debatable. I've touched one, yeah. A 35-foot female that washed up in Humboldt. No, it wasn't. I took my 1-year-old daughter to see it. We petted it together and cried. You guys know why I'm obsessed with the sperm whale? You guys are aware that whales are mammals, right? So they have to hold their breath when they go underwater, right? Anybody know where great giant squid live?
Way down.
Very deep water. So check this out. They hold their breath, swim below the photic zone, holding their breath into total darkness. And by total darkness, I mean there is no photon reaching your eyeballs. Then, holding their breath in total darkness, under bone-crushing pressure, hundreds of feet below the surface, they do battle with a prey species that can kill them in return. By themselves. Greatest animal ever.
Isn't that like video?
No, and they've been seen eating a satisfied meal at the surface. They've also been seen bobbing to the surface after dying in battle.
How does the giant squid go?
The giant squid has clawed tentacles that they use to trap their food, and then they eat it. So they have their like feeler tentacles, and then they have the two long ones that have claws. And so they'll latch on to the whale, and all they gotta do is hold it underwater long enough while the whale's trying to go get another breath, because it's holding its breath because it's a mammal! The one that I saw was relatively young, and she was covered with scars from wrestling giant squid. Or Humboldt squid, probably. Their main food source is probably Humboldt squid, or depending on some parts of the world, other local larger squid. But they do eat, we believe, giant squid and colossal squid. Is that not badass? Am I the only person that's impressed by this?
How large are colossal squid?
Well, they're
Colossal. Size. Foot.
they're pretty freaking big. I mean, Google us this answer. Maximum size colossal squid. No, I said I mean.
Right.
You know, if it's out, it might fall. I can keep it safe for you. Alright. So these predators, what do they tell us about our environment? Imagine I find a square mile in the Sierras with one
90
black
feet
bear.
long,
What?
90 feet long.
Oh,
How big are spermos?
Yeah, how big?
Google.
Sperm whale?
Imagine I find one square mile in the Sierra with one healthy resident black bear, and I find another square mile in the Sierra with 8 happy resident black bears.
50 to 60 feet.
oh.
But they weigh like 18 tons.
But they are holding their breath. This is like,
Why do you want to see?
okay. What do I know about those 2 different square miles in the Sierra? One has 1 resident black bear, one has 8. That's right. There's more food to provide for the 8, right? So what do we call a species that tells us something about that environment? It signals something about it. There's a term you all need to know. In some parts of the world, they don't call it turn signals. They call them turn indicators, indicator species. Those that tell us stuff about the environment. Because look, in 1 year, let's just make up some numbers, okay? This is just totally off, like, you don't have to be right. Let's make up some numbers. In 1 year, 1 mountain lion, if it only ate coyotes, how many would it probably need to eat?
Yeah.
Let's call it 20.
1 a week.
Okay, 40. And if each coyote ate nothing but bobcats, how many bobcats would 1 coyote need in a year? 40 maybe? Could probably get away with a little less. Bobcats are pretty small. I mean, coyotes are pretty small. So each one, let's say that they need 30. I'm just making it up. What's 30 times 40? 1,200? And then, if a single bobcat ate nothing but California king snakes, wow. Do you think a bobcat could survive on 2 king snakes a week?
Nah. Maybe.
I think 2.
Is it like
I'll bet you between 2 and 3. So let's call it 120 each. What's 120 times 1,200? So 144, 1, 2, 3. 144,000 California king snakes to support that population of bobcats, support that kind. And then how many mice per snake per year?
A lot.
Well, 1 a week is probably the same
Yeah,
number, so
yeah.
50. So 50 would be like 6 million mice. Can you imagine how many elderberry bushes it would take to provide for 6 million mice in a year? Like, you've heard about, like, vermin, right? Like eating your silos of grain or whatever. 6 million over a year. This would be lots. So watch. To support 1 mountain lion, you need a lot of coyotes. So you need a lot of bobcats. So you need tons of California king snakes. So you need tons of mice, which would require, I don't even know how to fit it in here, lots of productivity. Agreed? Predators indicate overall productivity of an ecosystem. Thus, please look up, when you see multiples, then that means there must therefore be a much larger multiple of productivity total. There's a lot of nutrients being made into macromolecules in a system with a lot of predators. Is that obvious to everybody? Does anybody think it's a coincidence that the yellowtail started hitting the 4 Mile Reef last week And yesterday, David Corrient's dad, Brian Corrient, posted to YouTube a video of what? Great white shark slaughtering a sea lion. If you look in the background of his video, there's a moment where my boat's in the background. I was coming out of the water from swimming when we said, hey look, there's a bunch of birds over there. I wonder what's going on. Should we move? And everybody's like, yeah, after this trip, we'll go check it out. But the vision was good, because, you know. Okay. I hope this isn't too obvious. There's just a few words that we've got to get underneath our belt. This is going to be like all year long, laying the groundwork. There's a few critical layers, like what would happen if we got rid of all the primary consumers? What would happen? Right. It is the proverbial, please look up, broken link in the chain. And a lot of day-to-day civilians can't figure out why all the hippie environmentalists want to protect like the crickets and the cockroaches. Everybody's like, sure, I like red-tailed hawks, but I hate mosquitoes. Pollution, crazy pesticides, and little changes in habitat. Keep doing this. They're just like chipping away. It's called undermining the food web. Because as you cancel out some of this, you're going to narrow out this, and then you narrow out that, and you narrow that out. What happens if the mountain lion only gets 20 coyotes in a year? That's right. And so the first thing that you'll see is the disappearance of the predators. It's a very challenging thing at a campfire when people are scratching their mosquito bites and complaining to explain, no, actually mosquitoes, you know, the food web and the thing, and they feed all the, and you can't get any mountain lion with no coyotes. But you have to understand that, it's a key concept. And likewise, the decomposers. Everybody's like, boo for bacteria, boo. Anybody imagine a world after all the decomposers have gone extinct? Everything then would build up, and then what?
There'd be no nutrients left.
There'd be no nutrients left, and then what?
They don't die.
It would be the end of life. We would be surrounded by dust. No more decomposition. It wouldn't smell bad. You would just desiccate, and the wind and water would break you up into little crumbs of ashes. And again, the same thing. Little changes in water quality really affect bacteria. So like CO2 makes rain a little bit more acidic, and pH sensitivity is extreme in microorganisms. So the bacteria are all like suffering, and decomposition rates in many environments are going downhill. You're all packed up, but I'm going to use my last 2 minutes. I think that number 9 about the non-native beetle and number 10 about the little organisms, those might be simple enough, but I really want to focus on number 11 right to the bell. Why does diversity give you resiliency? Yeah.
Because there's more diversity in the food that consumers can eat, they have more choices, and so if that goes extinct, they can.
Why would they go extinct though?
I don't know, if you like.
Because the environment's always changing.
Yeah.
The concept of climate change is sort of absurd. The word we should be using is man-made climate change. Climate's always changing. The environment's always changing. It'll be wetter or hotter, today it'll be cooler, whatever. Hold on, let me finish. You have the nutrition break, hold on. Because all ecosystems are always changing, we have to maintain diversity so that you've always got choices. Like if I go to the Sizzler and they're out of garbanzo beans, I can still make a salad. But if I go to Garbanzo's R Us and they're out of garbanzo beans, I starve. That thing about diversity and resiliency, I hope you have a good way to explain that. It's a critical concept all year long in our class. It's not about which species, it's about more species. That's worth writing down. It's not about which species, it's about more species. I hope you understand what I'm saying. Have a great nutrition break and I'll see you all tomorrow. Don't forget your homework.